Hello again, everyone. This is Jean here from Linkurious. Thanks for joining us today. We will be talking about reinforcing anti-money laundering systems with graph technologies. So first, let's talk a little bit about the agenda and of today's webinar. My name is Jean Villedieu. I'm one of the co-founders of Linkurious.
And I'm Elise, Marketing Project Manager at Linkurious.
So we will start today's webinar with an introduction to Linkurious and explain what is the graph-based approach, go into an overview of anti-money laundering, then explain how Linkurious can help strengthen AML frameworks. Then we will do a demo and finally provide a technical overview of Linkurious. So first, introduction to Linkurious. Our main product is called Linkurious Enterprise. It's a software used to identify and investigate insights hidden in graph data. It is currently used by over 200 customers around the world, including by companies like the French Ministry of Finances, NASA, Cisco, and other government or corporations. It is trusted to solve some of today's most complex data challenges, including anti-money laundering, which will be the topic of today's webinar, but also intelligence analysis, cybersecurity, medical research, or data lineage.
So, Linkurious capacities actually rest upon graph methods and technologies. So I will briefly tell a word about the graph-based approach before jumping to AML. So the graph approach offers a method for the analysis and the representation of complex networks. The idea is that the data is stored as a network of entities called nodes and relationships called edges. This enables specific analysis methods such as link and network analysis or graph pattern detection. To store and query large graphs, graph databases emerged at the beginning of the 21st century, and their popularity have been skyrocketing in the last year. So now let's dig into today's subject, anti-money laundering or AML. AML is the answer to a financial crime, money laundering, which is the practice of converting proceeds from criminal activities into legal assets to conceal their true origin. It is often combined with other criminal activities such as corruption, terrorism, or tax evasion to hide and transfer the funds to commit those crimes. So money laundering can be detrimental to an organization's reputation, profits, and to its future. So AML is a set of procedures, law, or regulations designed to stop money laundering. They are often defined after the recommendations of international organisms such as Financial Action Task Force. And those regulations apply mainly to credit and financial institutions, but also, in some cases, to non-financial businesses and professions, for example, casino or real estate agents. To, to understand how graph technologies can help organizations fight money laundering, we're going to quickly present AML common procedures. Anti-money laundering programs often consist of three layers: know your customer, transaction monitoring, and name screening. The first layer, know your customer, combine customer identification program and customer due diligence. They are the processes of identifying and verifying a customer identity. So a lot of data is collected at this point. In some cases, a more advanced investigation about a person or a company is required, and this is enhanced due diligence, which is intended for at-risk clients such as a polity person. The second layer of AML policy is transaction monitoring. It is responsible for screening the customer financial transaction to detect suspicious activity based on defined rules. And the third layer is name screening, which is the The purpose is to screen a customer names against a wide range of sanction lists. So those lists can be established by public authorities. It's the case for national lists of designated individuals and entities, or for politically exposed person lists. But the problem is that the global tendency in the field make it difficult for financial institutions to apply efficient AML programs. First of all, they face an important data overflow. The data sources are growing as well as the volume and the complexity of the datasets. And despite efficient storage tools such as relational databases, it becomes more complex every day for institutions to organize and to make use of their data. Querying connection with those systems are compute and memory intensive operations. So, in addition, there are often multiple siloed solutions within financial institutions because one solution is often deployed for one specific layer of the AML program. And these solutions are sometimes aging and inadequate to meet today's business challenges. Financial institutions also face a strong pressure from the regulation control organism. Regulatory expectations are growing, and institutions witnessed important regulatory development. Plus, compliance failure result in large-scale penalties and very costly enforcement action. Finally, financial institutions have to deal with a more complex fraud tactics nowadays. Fraudsters deploy very sophisticated tactics to hide their wrongdoings. For instance, they use shell corporation, intermediaries, tax haven, or complex financial scheme to prevent identification or tracking of money flows. And the transaction often involve deceptions that relies upon layers of indirection which can't be uncovered without the analysis of connected data. So these trends quickly become technical challenges if they are not being taken care of. And the analytical tools backed by relational databases make it hard and complex to investigate networks, which means analysts are unable to connect dots from disparate data sources and transform data into insights. It, it also becomes difficult to detect a pattern or to investigate relationship using traditional representation of data, like tables from relational databases. And finally, siloed solution can generate compliance reporting difficulties between analysts and business managers. So, as an overall result, this generate important losses for companies. The investigations become time consuming, increasing the AML program cost. The IT structure are also costly and require important maintenance. And if a compliance failure is reported, the bill can get very high. For instance, BNP Paribas Bank was fined last year $8.9 billion after not respecting US international sanction list. So, now that we have some insights about the AML field, let's see how Linkurious can meet these challenges. Linkurious is indeed built for teams of analysts and is perfectly suited for AML procedures. One of the main advantages of tools like Linkurious is that they enable people to find insights in large-scale graph. First, graph technologies allows you to store and to query graphs of billions of nodes and edges. And paired up with the Linkurious interface, you get an holistic view of those large volume of heterogeneous data. There is also visual representation of relationships, which are directly showing how entities are connected. For instance, it could be individuals, transactions, or accounts. So you get to discover non-obvious connections within your data. And because it's visual, it's also very easy to investigate multiple layers connections. The second advantage comes from enhanced monitoring capacities. In Linkurious, you can monitor specific fraud patterns thanks to the alert system. For instance, you could get an alert when a transaction is connected at one point to a suspiciously large number of persons, or you could get an alert when large amounts of money are frequently moved in and out of a customer account. With the graph approach, patterns can include cross-data checking or multiple ops layers. So analysts can automate this monitoring process, putting as many alerts as they want and still get insights in near real time. It's also possible to add watch lists in the database to detect existing connections between clients and expose individuals or companies. So finally, we've designed Linkurious to be a collaborative and adaptable solution. We have previously seen answers to problems that belong to different AML layers. So Linkurious can be used for a different compliance program and processes, which is a good way to save money. We also offer a solution to directly integrate Linkurious into your existing environment with the Linkurious SDK. So in the end, we've made it easy for analysts to collaborate together, and thanks to advanced feature, it's very simple to work as a team in Linkurious. Analysts can also easily extract and share visualization, and many formats are available to best suit the reporting needs of your company. So
Thank you, Elise. Now let's dig into the specifics of how Linkurious can help with anti-money laundering. And for that, we have prepared a demo for you. So first, let's talk a little bit about the dataset that we will be exploring together in the demo. So here we can look at a schema detailing what will be in our data. We are talking about some dummy data, obviously, not real world data. And the data that we are going to be investigating, we will have a few key entities. We will have bank accounts, and here we can see on the top left a bank account. It is connected to a transaction, but also connected to another bank account. The first bank account here is attached to a company. So this company here has a as bank account relationship with the bank account, whereas this bank account here is tied to a person who also has a bank account. Okay, and then we can see that both the person and the company are linked to addresses by a as address relationship. So here we have first address and there a second address. And finally, we also have each other of relationships in a data set. And these each other of relationships can be between either companies or a person and a company. So that's a brief overview of what is in our data. Now let's get started with the Linkurious Enterprise demo. Okay, so here we can see the interface of Linkurious, and that's what we will be using for the purpose of today's demo. We will be looking at two main scenarios. First, an investigation scenario where we start with a particular person of interest and we want to learn more about him. And then we will review to detect suspicious activities automatically and review alerts. So first, let's investigate a person called Jose Pierce. We have heard about him as a potential fraudster, and we want to know more about him. So I'm going to type his name into Linkurious. We can see results popping up, and I'm going to actually open a result regarding Jose Pierce, so I can see some information about Jose Pierce. Okay, I can see that Jose is tied to an address. So as a customer, he has registered an address. Looks like it's based in South Africa. Okay. We do have some information regarding Jose Pierce, including the fact that he's Russian. He's not on watch list. Okay, and he has an email which is this text here. Okay, so Jose has a bank account. I can see that this bank account is tied to 33 entities. I'm going to double click. And what happens now is that we see all of the entities tied to the bank accounts. And all of these entities are transactions. So here, for example, we have a transaction, and we can see that it has a dollar amount. It's 93. Here we have another transaction, 39, and so on and so on. Okay. I'm going to pay close attention now to where Jose's money has flowed to. So I'm going to open up all the bank accounts. So I'm clicking here on select neighbors, and I'm selecting all the nodes connected to the bank account. Now I'm going to click on expand, and I'm going to click on ascent to discover where Jose's money has gone. Okay, so we dig deeper into the data, and we see that we have 3 new entities which appear. So we have a bank account here, another one here, another one here. So basically, we started with Jose, followed him to this bank account, and now we have uncovered 3 new bank accounts. I'm going to select the 3 bank accounts, and I'm going to click on expand to uncover the relationships between these bank accounts and first 2 companies, okay, and then 1 person. Okay, so what we have done is that we have discovered which entities are connected to the bank accounts with which Jose's bank account has been associated with. So here we have a company called Buzzbean. I can see some information regarding Buzzbean. Here I have another company, and I can see some more information regarding that company, including a description and a name. Okay. And here we also have a person, a Russian national, it seems, a Catherine Miller, with an email address, and so on and so on. And I can, keep on expanding and learn more about, even learn more about what Catherine is connected to. And I can double click to learn that, or I can, look into the 2,000 and more transactions associated with that bank account. So with Linkurious, it's very easy to explore the hidden connections in the data. Okay. So here we've uncovered some information regarding Jose, and specifically we uncovered which entities is directly in contact with. That information can be used, for some follow-up investigation, and perhaps I can, try to learn more information about Buzzbean and Rezio, for example, as a starting point. But right now we are going to leave that investigation here and talk a little bit about how to detect patterns automatically. So I'm going to quit this visualization, going back to the dashboard, and I'm going to save that visualization, give it a name. It's Jose Pierce, so that it will appear in my dashboard, and I can go back to that investigation at a later point. And let's talk about the alerts. So first, alerts are set up by administrators, and here we can see that we have set up 1 alert, which is built to identify at-risk transactions. So it takes a graph pattern. Here it's a graph pattern typed in Cypher, and runs that graph pattern to identify subgraphs. So what that pattern here does is that it identifies transactions here which are tied on a degree of four distinct relationships with a person or company with on a watch list. So basically, we are looking at a transaction tied to someone or something on a watch list. Okay, we are going to close that, and we are going to turn to the alert dashboard. Okay, so I'm going to focus on the at-risk transactions, and I can review all the results of that pattern. I can sort them by the time, by a score, or by any property I want to. I'm going to focus on the first result here, so I'm going to click on that. So that result was generated with the alert that we reviewed, and it shows us that information. So we have a transaction here. Okay, so I can see some information regarding the transaction. We do have an amount. Okay, and we can see that it's tied to a bank account, which itself is tied to a company, tied to an address, and finally tied to a person. And what's interesting here is that we do have a person called Angela Marshall, who has the yes value for the watchlist property. So what that means is that in the context of a demo, this is a dangerous person and someone on a watch list. So it is normal that the transaction should be flagged, as it is it is indirectly associated with someone on a watch list. Specifically, we have here a company with which we are doing business tied to that transaction, but also sharing an address with Angela Marshall. Very good. So what's interesting is that we can see that 5 other entities are tied to the address. So I'm going to go ahead and double click and see what happens. So we have some interesting things that pop up. First, we have 1, 2, and 3 companies. So that's definitely something of interest. It seems to be an address with a lot of activity. And then we have two employees. Okay, we are also tied to that address. So we do have a situation which seems to be quite interesting with first a company doing transaction with a bank, also tied to an address with at least one person associated with on a watch list. But then we have two employees who are also associated with that address. So it's definitely something very suspicious, and it warrants some more investigation. If I want to, I can display the data to see exactly where the situation is happening. Okay, zooming out a little bit. I think we are in China, and we can see where it's located. So it's in the mainland. Okay, and I can zoom in to see exactly which street, which part of the country the address is. If we want to, we can save the visualization. Let's call it SAR1 for suspicious activity report. I'm going to save that, and I'm going to perhaps want to export it to some file formats, including Excel or CSV, or perhaps a PNG or SVG picture. So it's very easy to do that, and I can use that to actually communicate my findings to colleagues or to outside parties. But I can also share the visualization with someone else. I simply have to type his username, and I will be able to give him access to the result of my investigation. Okay. We can also do some more advanced interaction with the data, switching it from this force directed layout to a more hierarchical representation like that. Or we can filter the data to perhaps remove some non-relevant entities. Let's say that we don't want to display the employees. So I'm going to select all the entities except the employees to filter them out from the visualization. Let's say I want to manually remove that node, I can also do that. So it's very easy to basically slice and dice the data based on the analytical needs. Going back to the dashboard now. So what we have seen is that it's very easy to use Linkurious Enterprise to not only investigate a particular person of interest, but also to monitor data and identify potential anomalies.
Thank you, Jean, for this demonstration. So yes, as you said, we've seen that Linkurious is a great fit for AML analysts. The graph approach allows to get a 360 data view in a single network. We can then apply graph analysis tactics to find hidden insights directly in Linkurious. And the additional features are also a perfect tool for analysts to take advantage of the data. The alert system, as we've seen, for instance, is a good way to automate threat detection. And it's easy to set up alerts based on a complex pattern or to include watch list. And the results come in near real time and can be assessed immediately. Sharing and collaboration feature are also important for efficient teamwork. In the end, Linkurious helps financial institutions to reduce the complexity and time of investigation to save money. So we're going to come back to the presentation for the last part, which is the technical overview. So on a more technical note, Linkurious is an enterprise-ready platform. We have an on-premise web application that is compatible with the modern OSs and browser. On the database side, we are fully compatible with the best product on the market, such as Neo4j, DataStax Enterprise Graph, Allegro Graph, or Titan. And we also provide a documented REST API for custom integrations. And finally, enterprise security is one of the main concerns at Linkurious. So that's why our platform is compatible with numerous external authentication protocols and services. Companies can also manage access rights for their user and specify them on an entity type level. And we have an audit trail that is available and provide documentary evidence of the sequence of activities for every users.
So thank you everyone for tuning in for today's presentation, and thank you Elise very much for explaining how to apply Linkurious to anti-money laundering. Now is the time, if you have some questions, to type them in the chat. I think we do have a first question from Richard Ed, and I'm going to read it. How can you understand chronology, time order of customer activity in this model? So in the model that we analyzed today, we didn't have timestamps in our data, but typically it's something that could be in a real world scenario associated with the transactions. And then you could use Linkurious to either generate alerts based on this information, perhaps looking for a certain amount of transaction in a given period, or you could actually use the visualization interface of Linkurious to filter out data, nodes, edges based on that information. So thank you again for tuning in for today's webinar. Enjoy the rest of your day. Bye bye.